Hi, welcome back. Today I'm going to be introducing you to the general structure of pandas. I'll be talking about how to create a data frame and also how to install pandas. So installing pandas is actually very easy when you're using Visual Studio. So you basically just have to go to the terminal and type pip install pandas. So pandas depends on NumPy, and when you install pandas in Visual Studio, NumPy is automatically installed. And to start using pandas, you need to always import it into the workbook. So I'm using the Jupyter Notebook as my uh, IDE for this particular example. So if you're using Visual Studio and you want to use Notebook, I guess it automatically comes with Visual Studio. You just have to save your file with the extension IPINB, right? And you will have a Jupyter Notebook to work with. Import pandas as PD. The PD here means the PD here is just a placeholder that holds the Panda library. And so for subsequent data manipulation, you will not have to type the whole word pandas, but rather you'll be using PD as the placeholder for pandas. You will also need to import NumPy. So import NumPy, and with the same logic here, let's use NP as a placeholder for uh, NumPy, and let's run our cell and see if we'll get any errors. Yes, we got an error because uh, we did not bring as, so we just said import numpy, then we have space and then np. So it's all part of the process. Debugging is very important. So you are supposed to add as np. You run again, then everything is fine. If you get an error that is related to the pandas library, then it's probably because you have not installed it well, and you have to check your installation and make sure it's well installed. Right. So what exactly is a data frame? A data frame is just a two-dimensional pandas object that allows you to be able to store data in a tabular form. And with this structure, you are able to store data of different types into rows and columns. A data frame is size mutable. That means that if you're able to represent data into rows and columns, you can actually change the size of that data. So basically, Pandas data frame can be thought of as a dictionary with the keys as the column headers and the values as the rows of or the data under the, the column headers. There are different ways of creating a pandas data frame, but the most basic, the standard structure of every data frame is that first, when you call the word data frame, in it, the parameters of the word data frame are the first one is passing in the data that you are creating. The second one, and the second one, you may add you can add the column names of the data, and also the third one, maybe you can add the data type that you're creating. The fourth one, you may add the index of the data. The index here is just like a counter of the number of rows you have. But the most important parameter here is the data. You must pass in data, otherwise you will not have a data frame, right? And sometimes too, the data you pass into the data frame parameters may contain columns, so you would not need to include the column parameter, right? But the standard uh, the standard parameter here is the data. Let's look at this example here, right? So I'm creating a data frame and I'm storing it into a variable called data. So I'll type PD. PD here is referring to the Pandas model dot the keyword data frame, and into bracket I'll pass in the data, then I'll specify the columns. So as I said, the other parameters are optional. And so this data is a NumPy array. So you have different lists, and each list is like a column. And so if I pass in another parameter called columns and I specify ABC, then it will correspond to the data we have here. A corresponds to this data, and then B is the head of this data, and C is the head of this data. As you can see the output here. The extra column with 0, 1, 2 here refers to the index. Because we haven't specified the index, and it automatically, assigns um, the normal index in 0, 1, 2. If we had more data down here, then the indexing tool will continue counting upwards. As I kept stressing that a data frame can be thought of as a dictionary, right? A dictionary, but then in a tabular form, right? It's able to display dictionary data in tabular form, right? So let's look at this example, right? So I had this data frame that is in the form of a tabular form as it's supposed to be. I can literally create the same data frame but using dictionary, right? So I have a variable called D. If I print this one, then I have this output, right? It's basically the same here, but then this is represented in a tabular form, and here this is represented as a dictionary, right? Let's see display, if I want to have this data in a tabular form, then I basically just have to do the same PD dot data frame, then I'll pass in the data. Now the data here is D, right? So if I run again, then you see that now we have our dictionary being converted into a data frame, right? So in simple terms, Pandas data frame allows you to be able to visualize dictionary data in a two-dimensional form. Yes, you can also have data in different formats like Excel imported to create a data frame. So for this example, for instance, I have uh, data of countries which I stored on my desktop, and That is the directory in which I'm also working on. So that means that whatever file that you are importing should also be in the same directory in which you are working on. And the name of the file is countries.csv. So I just have to use the read CSV command. So I'll do pd.read CSV and I'll store it in a variable called countries. So let's just print countries by calling countries here, countries, and we'll run and see the output. Right. So I've basically imported data from Excel and I've created a data frame called countries. And this is the output. Notice that the number of columns here did, has not included this. So this, as I explained earlier, is just an index. It's just a counter of the rows here. It doesn't count as a column. Usually, it's always best to print the first four rows of the data, and that will probably give you a gist of how the data looks like. And you can always do that by using the head function. So here we do countries dot head, then we run again. Then here you see that it has displayed only the first four rows of the data. This will give you an overview of how the data looks like. You can also have a summary or get a summary of the overall data types of your data, right? You can do that by doing using the info uh, method. So the info, right, and print again. Right. So this gives you an overview or a summary of your data. So it says that you have 1,704 entries. So these are basically the number of rows, right? And you have a total of three columns. And it further summarizes it. So you have the index here, then you have the column. So this one displays the names of the columns that you have in your data. So it tells you that, well, you have country as a column, you have year as a column, then you have population as a column. It also tells you the number of rows in each column that do not contain null values. So, for example, with the country column, it says that 1,704 do not contain null values. That basically means that all the data from the country column do not contain null values. They all have values throughout. And it says the same for the year column and the same for the population. It also tells you the data types, right? It tells you what kind of data is stored in each column. So with the country column here, it says that it's an object, right? That is a string. Usually a string is represented here as an object. Yes. And also it says that the year column uh, has integer 64, right? And also the population has integer values, right? So it also tells you the memory uh, your data is occupying, and you can see it printed here, memory usage 33.3 plus kilobytes, right? So this gives you a very nice summary of your data, especially if you have large amounts of data. It's always best to start with this exploratory process that allows you to be able to better understand your data